So the talk's going to focus a lot about what we do at 6sense. 6sense, the product itself relies a lot on predictions. So it's very important for us to run a lot of models in production. And this talk is all going to be about the pipeline that we have built and how we started using H2O for a lot of our models right now. It also talks a lot about, we use a lot of scikit-learn still, and so I'll show you how we productionize models. On a given day, we have probably around, I would say, in our current scenario, we have a little under 200 models in production right now, with another, you can say 200 or 400 models that run in an experimental pipeline, where we are trying to see, can we change the performance of our models before we push them into production for our new customers? So that's what we'll focus on. I'll skip through a few things very quickly, but before we start, because we are in a predictive conference, I wanted to start with the prediction here and show you how this talk's going to be the best talk at H2O World right now for you guys. This prediction has been made by somebody. The problem is, as with all good data scientists, you need to look at the data. You need to see what it's saying. This prediction is only using one feature. It's being said by my mom. My mom thinks this is going to be the best thing ever. She always thinks it's always going to be the best thing ever. And as good data scientists, we know that this talk is going to have, or this prediction is going to have low precision and low recall. There have been much better talks that have happened here. So while we get that out of the way, let me give you a big overview about, or a small overview about 6sense in general. We find prospects that are in market to buy. It's a very small statement to say that we are finding prospects in market to buy. But if you think from a consumer standpoint, think about Amazon, think about Google, think about all these companies that are using your behavior and trying to figure out what they should be showing you. We are taking the same concepts and applying it into a B2B world, where it's very tough because all the data lives in different silos. They don't talk to each other. In fact, marketing and sales organizations don't talk to each other properly. And what we are trying to build here is we're trying to bridge the gap. We're trying to bring all this data together and at the same time power not only your marketing and your ops teams, but even figuring out who your salespeople should be focusing on. That's the lowest hanging fruit for us. And as a team, because our product is all about data, the predictions, we bring together all these things. We live and breathe data, and we live on statistics. And obviously beer. That's it. And something about me, I co-founded 6sense probably around 2.5, 3 years. It's a blur now. It was 3 years ago probably. We started as a small gig inside of Cisco first, and we started using our models and everything there. And as time went on, now we are live with some of the biggest customers out there, like our Salesforce, Dropbox, VMware, Dell. We basically power most of the systems. The sales team is the easiest to power for us, but think about doing personalization on the website. Think about doing the click to chat on the website. A lot of the data goes into those platforms, and they use these results for spending their money in a wise way. The fun fact, I had to use a sledgehammer to get one of my old Hadoop clusters off a rack. After the talk, I can get into details why that happened, but it was a lot of fun runs to fries and everything to get our first Hadoop cluster up and running. That was around 2008. So the problem, like I said, we are trying to predict who's in market to buy. We have to say a company is ready 90%, 80%, 70%, whatever that percentage term turns out to be, or whatever that ranking turns out to be, is in market to buy what product they're going to buy. That's the most important thing, because a company that is selling like Cisco sells to probably 40 different organizations or 40 different product styles, they need to know what product is this company going to buy and when. Because the when part helps them figure out, should I be giving this to a sales rep? Should I be wasting my salespeople's time? Should I be doing a marketing campaign to them? Should I be doing a brand campaign to them? Or should I just nurture them through some other cheaper advertising ways? That's the key in there is can you predict how much time is going to take? And what kind of data do we need to do these things? Now, obviously, it's a lot of data. Some of this is what we term as the first-party data set. Let's say our customers have their own web logs. You can think of them as Apache logs, but we ingest any kind of logs. We can take your Apache or your Omniture or your Mixpanel, any kind of logs. We take data from your marketing automation. Example is in Eloqua, or you can think of Marketo or Pardot out there. We take data from that. CRM, Salesforce is the biggest one out there, but you can think of NetSuite, Microsoft Dynamics. We take that data. The first step that we have to go through is munge all that data and bring all of it together so that we can start making features on top of it. We have to join all these data sets which don't join to each other in a good way. So that's where we've built a lot of algorithms to figure those things out. And on top of it, we add our 6sense data network. This is something that we are not always talking about a lot in open, but it's a data network that we've built over the 2.5 years where we have a lot of the publisher data, a lot of ad data, and a lot of blogs, which we use to figure out, is somebody doing research? Let's say I can tell to the H2O guys today that somebody's doing research on buying a data science platform outside of H2O right now. It's so much valuable to these guys that I'm pretty sure they can come and figure out whether they want to buy 6sense. Oops. OK, so one quick insight when we bring all these things together is research patterns are very different. We all know it. When you want to buy shoes as a consumer, you go to a site, you find your size, you find your color, you find your brand, you click one click, and you buy it. But when you want to do let's say you want to plan your travel somewhere, you spend some time doing it. Let's say you want to buy a house, you spend some time doing it. We already know from those kind of things, there is going to be very different research cycle of when you start putting up your hand, when you start browsing around, when you start searching around. So we have to take those things into account very well. And when you do those, let's take open source tools like H2O. We all just go to their website and download their tool, right? That's the first thing that we'll do if you want to try H2O. You're not going to go and say, contact me. You're not going to say, go and check pricing. There's a very big difference in how you buy expensive routers versus how you buy open source tools. So based on that insight, what happens is we have to build a different model for each product that we are predicting for. Product is a misleading term because let's say we sell to Cisco today, which is for routers. Tomorrow we sell to Juniper for routers. We cannot use the same model. We can use the same insights. We cannot use the same model because the time to sale or the time how it works is going to be very different when you think about how a sales organization like Cisco or how a sales organization like Juniper works. So it's very important that we have to have a different model. If we want to succeed, we have to have a different model per product. And plus, because we are all engineers and we all love to overtly complicate things, we decided to not make our lives easy. And we need to build 4 models per product. And this is actually more detailed into how the product works, because what we do is we try to identify an account that is ready to buy. And that ready to buy is they're doing research. Then we need to find, is this the right kind of account? Do you sell into these kinds of accounts? So that's what we call the profile model. So that's a separate model. And under those accounts, now we need to find which contacts are doing research and which contacts are the right people to talk to. Because the H2O sales guys don't want to go and talk to some salesperson. They want to go and talk to data scientists at a company because they are the eventual buyers. So that's the profile of a person that you want to go to. But there can be different people doing research everywhere. So that's why it's 4 models. And that's 4 models in production. And we can have multiple models that are running in parallel in an experimental pipeline if you want to change things around. So like I said, we already have, this was me preparing a slide last week. We just onboarded a few customers. We have probably, I pushed last night, 180 models in production, 80 of which are running via H2O, and a few others are running via scikit-learn. So let's talk about the pipeline. Like I said, we sync data from a bunch of sources. There's all these API integrations that we have done. We've written a lot of custom syncs and file drops. All this data goes into our storage platform, which in this case is mostly HDFS or backed by S3, depends upon how fast we want to process things. And then we standardize. Standardize is the most important step here for us because, as you all know in data science, garbage in equal to garbage out. You cannot put any garbage into your models. You have to standardize. You have to clean. You have to figure out a way that you have established patterns and make that data go through it. We would not operate on any data coming into our system without it going through our standardization pipeline. It has to fit into our view of the world, how a B2B marketing org works, how a B2B sales org works. And post that is what we call magic or data science. So like I said, the pipeline now breaks down into a series of DAGs. We've built our internal tool. This is something that we've not even open sourced yet. We'll probably think about doing it. It's every node in our DAG. This is very high level, and it's basically a big chunk of like calling web. We try to break things into very small individual items in a DAG, so that what we can do, what that allows us to do is, when we are experimenting with data, we can remove a node and let the whole pipeline run without actually having to do a lot of changes. If you start doing a lot of code, like if you start writing monolithic, big, giant scripts which do everything, it's going to be very tough for you to experiment with any kind of features or any kind of things that you want to do. So we break down everything in the smallest unit of work and then let that work do it. We'll rewrite that data out and then let the next task take it forward from there. So once we identify, so like I said, we have to identify companies, we have to identify contacts, we normalize, we master the data, we do fuzzy matching, we do a lot of processing before we end up going into the modeling and scoring phase of our system. And once you enter modeling now, modeling is, it's actually almost like a misused term. Like, I feel people always say, like, take the data, prepare the features, done, start putting your labels, and then start predicting, looking at your ROC or AUC, and then look at what is happening. The problem is, an ROC or an AUC is only as good as what you gave to the model. I can show you models, and I can tell you stories where we even found dead people, but the problem is, an AUC will give you information, and I can show you that it's amazing, but the model was complete crap. Just because of the way we normalize the data, just because of the way we standardize the data, it's a function of what you do with your features. So what we do, and this is after a lot of iterations, what we started doing was, our first step is what I call on the left side is run statistics. It's blind statistics on the data. It's not even trying to do any machine learning. It's not even trying to do anything on top of it. Just tell me, it's called group by queries. If you guys don't do group by queries on top of your data before building features and everything, you're doing a big disservice to yourself. You should be doing group by queries. Just figure out what is it the data trying to tell you right now. Once we run those statistics, we have an automated pipeline which takes the statistics of that data, the probabilities of some values converting, the probabilities of something influencing your eventual outcome that you're predicting, and we build a baseline model. This baseline model is generated using SQL. It is a pure SQL function. It's what we call, if you are a data scientist, and if you are somebody who loves to work with data, you should be able to beat my baseline. If you cannot beat my baseline, at this point, we would not push the predictive model into production. And the reason you want to do that is because without having a baseline conversion metric which can be derived, because again, the B2B world is very different. The B2B world, nobody knows what their conversion rates are. It's very tough to tie things together. So it's not as good as the fraud, online fraud and everything that you're trying to detect. So that's why you have to prepare something which a data scientist can beat. Once we do that, what is that whole block of model statistics that we call? The model statistics at this stage is looking for things besides your ROC curve and your AUC. It does look at it. I'm not saying it's not something that you should not look at. You should look at it. What we look at is we take the data, we sort it over, like we break it into like equal deciles of data. We try to figure out what is the decile conversion point for each data set that you have. We use a cross-validation and everything on top of the data, so we'd use a tenfold, but we also hold out a blind set, complete blind set, which we know the performance of, and that performance has to be met always, or you have to beat it always. So the model stats part is very important. If you want to run multiple models in production, you have to do that. And now comes the predictive part. Now we can take all that data, all that statistics, everything that we were doing before, and as a data scientist, this is where your money is. You go in, you start building features on top of it. You can build different kinds of models. You can build, you can even try like very complex techniques. But from our findings, most of the times, the thing that again works is go back to the data. You can try running a GBM model. You can try running a random forest. You can try running anything you want. You can probably tune it a little, maybe a little, but if you go back to your data, you might be actually able to get the most benefit out of it. So you have to go back to your data overall. All these things are what we call, and this is where our data science team sits mostly. And so they can play around with the DAG how much ever they want, as long as it's in that green, as long as it's in the red bucket, colorblind probably. So let's talk about the modeling part, what the teams do. We have 2 kinds right now. We had 3 kinds before, but we have 2 kinds now, scikit-learn and H2O. We were using R before, but we started wrapping H2O into R for a lot of our use. After the model is built, the team is happy about it. It produces 2 kinds of output. One is pickle files for all the Python stuff and a POJO that H2O outputs right now. And then we've written a homegrown tool right now which allows us to promote a model to production. What that script does is it takes all the artifacts that were used when we built the model, it versions them, puts them in S3, and then it has the original data, the training data that you used, it has the test data that you used, it had the blind data set that you used, and it has all the queries that were used to prepare the data. The reason we do that is because we have all this thing in Git, all that fun is there, but eventually you want to keep it there if you want to go back to it. The most important thing there, and which we actually look at very well, is the stats. The stats are nothing but images or like tables that were prepared when we were comparing the data. Those stats also go into our S3 bucket for all those version models. What we do when you push something into production, we have this meta store that we have created called the model info here. The key fields in this thing are obviously the name, what is the name of the model that you are working on. The type here allows us to do pickle or POJO. Now, the type is something that we use during runtime to load a model dynamically. We have an infrastructure based on Mesos, Docker, and we use a lot of Marathon. We run these things asynchronously. When a message comes in that you need to run a model on it, we know what kind of model it's going to run on. We load the information about the model from here. The binary location tells it whether it's in S3, whether it's in HDFS, or whether it's in Git. We used to use Git before for big files, but we don't anymore. And active flag basically tells us what's in production today. You can have a lot of inactive stuff which is still running every day, but it's not in production right now. While we are promoting models like this, it allows us to look at how many different variations of a model do we have, what kind of different techniques have we tried, and it allows us to also look at some of the changes that are being made to the system. And this meta store is simple. It's just backed by a PostgreSQL right now, but it's simple. And then if you look at that model table, what happens is we take that table and we have an automated deployment process which takes each entry into that database and creates them as DAG nodes in our system. So you can have n number of models running. Each model gets tied to its model stats, and only one of them is actually continuing down the production pipeline. Everything else is going down the monitor performance pipeline. You do that because of the fact that, like I said, I wanted to compare what is going on. Our data science team can build some models. We are looking over performance over time because we don't want to change something that is working in production without actually saying that I have confidence that this will work better or not. Then the key overall is going to be what I call is experimental modeling. As data scientists, you can build a good model. We can give you new data. As we bring in new data sets, we want to change our existing model. Like say, I can go out and buy a data set which allows me to see what other activity somebody is doing on a website outside of our customer's website. But we don't know how to introduce that into the model. We might not have enough historical data for it. I can go back to my data science team and say that, hey, I want you to build and try and use this data. Tell me whether this data is useful or not. Should I go and pay the money that is being asked of me right now? They can build an experimental modeling pipeline. It follows the same pipeline that I mentioned before. They can introduce a node in between. We look at the stats that comes out of it, and then we look at day-over-day runs to see whether actually it impacts anything. And when I say impacts everything, it's very important because the stats, like I said, ROC, AUC, good to promote something into production, but the stats that I'm looking for is how much does this data set change my top decile? is it actually materially changing things? Like, are people who are at the top of my list moved to the bottom of my list because I added this data set, and how is the conversion going? Did it actually promote some of the people in the bottom of the data set which were converting to the top? And if it did all those things, and if it did not do all those things, was it just a shuffle of things? Like, you can have like the top 2%. Let's say top 2% is something that a salesperson is going to call on definitely in a week, right? If that 2% is only getting shuffled around, this data set wasn't that important to us, because we just shuffled it. Whether you shuffle it or not, they're going to reach that 2% anyway. You're not going to get a chance to improve on their performance. So we don't want to pay for this data set because of the amount of impact it had on our performance. The way we do the experimental pipeline, like you see all these models running in production, the data scientists don't have to care about where is this data going. We use a lot of templating. A lot of our pipelining work is done in Python. We use Jinja templates to figure out which table you should be writing to. That table information comes from that model info table, saying like, I will be running this experiment. It'll go, the output of this data set should go into this table. And then the next stage knows, okay, you wrote output to this table, I can run some stats on it. One other thing that we noticed very well works when you're comparing stats is when you are collapsing a lot of data, when you are merging a lot of data sets, you can end up doing very bad things. You can end up cleaning things in a weird way. You can end up, I just had this example today where we found like a very bad mistake that we did was, you want to classify somebody as a vice president or some kind of vice president at a company, let's say. We put a feature in there, and the feature was trying to be smart about what it was trying to do, but it only looked at the word executive, and it only looked at the word vice presidents in there, and it forgot to filter out people who are called executive assistants. So an executive assistant became an executive vice president, a C-level person at a company, which basically causes problems, because if you give those kind of people back to a sales team to call on, they're not going to like your model performance at that stage. And those things we can only catch by looking at some of the raw data that we did, because it's too late to look at a feature because everything was collapsed. You don't even know what happened there. So we had to go back. Once the top things are scored, we go back, we have all the data that was stored, and we know where the data came from. So that allows us to see what was being done overall. In reality, I'll show you the script that our data scientists write. You can be surprised how, because of our smaller things, or the small size of code that we have for each step, the amount of work that a data scientist needs to do is not that much. We are completely on AWS. Our backend runs Hadoop, Hive, Presto, Spark, Redshift. Think about any database out there, Postgres. Like, we have so many different things in there. We use the best thing that is available for our thing to do. Machine learning, H2O, scikit-learn right now. We use a bunch of R, but it's mostly to plug now kind of H2O stuff. And our ops is, we use Fabric for deployment, Mesos, Docker, Marathon, and a bunch of homegrown tools. The good part for our H2O stuff that I would like to say is, like, H2O outputs the POJO for us. We build our tools and our script that promotes things to production. What it does is, let's say you're a data scientist, you build a model, you output a POJO. We take that POJO, you run that script, it compiles the jar, and then it puts the jar into S3 for us. And then during runtime, when our Docker image loads, it downloads that jar, adds it to the class path wherever you want to run it in Spark or Hive. And then it can dynamically load the class that is whatever GBM or dynamic like random forest, whatever you ran. It'll load that thing for you, and it'll score stuff. So the things that you have to do as a data scientist overall is just make sure that your features are right and your model will work with those features. As long as that happens, it can load anything that you want. So I am going to keep it short. I wanted to keep it short and sweet, given I was the last person and everybody wants to go drinking. I'll open up it to any questions that you guys have.
I actually do have a question for you, and it is from someone who asked on Twitter, which is, he was wondering, what business domain generates 3 billion events a day? How do you define an event in your example?
Oh, that was actually from my previous cluster. I used to work at Hulu before this, and we had a daily incoming logs of log data that was coming in. That was upwards of 3 billion events per day right now. Or when I left, there was probably a lot more right now. And we used to process all that data to do our reporting, financial, recommendation, machine learning on top of it.
Any other? Oh.
Oleg.
Hey, Viral.
Hey.
How did you guys do this before? I mean, it sounds like you automated a lot of tasks.
Yeah, we had code monkeys before this. Before this, we used to, I mean, it was a pain. The reason we have so many models from H2 in production is just because of the ease at which we are deploying and running these things in Hive right now. Previously, we were using Python, scikit-learn, pickle files. It was such a pain to distribute them. With pure Java objects, it makes our life so much easy to like get that thing out there and not having to need everything that is the fun stuff of installing all the Python pandas, NumPy, and everything. So it definitely reduces our pain and allows us to move quicker. That's why we have so many experimental modeling going on right now.
So that actually leads me to a question. I saw that you've got all this support for provenance, right? So we can see, okay, here's the stats we ran, here's all the things we looked at. Have you had cause to go back and then use that provenance? Because one of the difficulties is if you put all this stuff in, but often you take inadequate notes as to why you did all these things, and then you kind of can come back and there's always this problem of, oh, well, I collected all this stuff, but it meant something to me only at the time. Have you had those kinds of issues, or how do you address that?
Yeah, I think one thing I should touch on is we generate the stats almost every single day. All those stats that were generated are regenerated, and we keep that data per day. And so we do go back to them. There are cases where we have also found that so we find interesting things like the stat was only as good as the query that was run, or as good as the normalization that we did at that point in time, right? So we can look at like, 15 days ago, we were able to match probably, let's say, 5% of the database. But with our changes that we did to the platform, now we're able to match 10% of the database. Is that what materially impacted a model or not? So yeah, we do go back to those things. And sometimes we throw away some bad things that we did. And it happens all the time with data. Like, it's surprising how many times you can go wrong also.
Thank you. We have one more question. Yeah.
Yeah. You have mentioned using advertising data as part of the data sources.
Sorry, which data?
The advertising data.
Oh, no, we don't use agriculture data, no.
Okay.
Yeah. We only sell, our major client base right now is all B2B tech companies right now. But next year we are going into manufacturing, and so probably we'll start looking at that data set.
Okay, so
one more question. What is the typical size? What is the typical size of the Pojo are using in the production, like in megabytes, or do you have like?
Fun fact: we broke our. We had a problem where we could not load a Pojo in production probably 2 weeks ago. I think we ran into the perm gen space issue and everything in there because there's a lot of static stuff in there, and it causes problems. So I think the biggest one that broke it around that time was probably a little over 200 megs or 300 megs, if I remember. But we are trying to figure out a way to clean it up a lot more so that we don't end up with that large Pojos. But fun fact for H2O guys, don't use so much static stuff.
Thank you. And one more question. Do you think about using other languages, like not only Java, so we can like use Pojo, like C Pojos or Go Pojos? So
we do have some C code recently being pushed into production, and we wrap it all in there. So we do have it. We don't wrap it as a Pojo. We wrap it as a C binary right now, and then we use it to call using the Java interfaces overall. But we are not that heavy in C right now. We are more heavy in Python and Java. We might with NLP. We're trying a lot of NLP techniques now, so we might actually go there.
All right, thanks. So everybody, let's thank our speaker.
Thank you.